Welcome to the Deep Dive. Today, we are really getting into a story that's, well, it's more than just catching a bad guy. It's about this incredible moment where forensic science and, everyday technology just collided.
Absolutely. And it changed everything. We're talking, of course, about the Golden State Killer, Joseph James DeAngelo, and how he was finally caught back in April 2018.
Right. And it wasn't your typical police work that got him, was it?
Not at all. I mean, this capture was probably the biggest breakthrough in modern cold case history. This case went cold for decades. Traditional methods, they hit a wall.
So what changed?
It was this combination of old crime scene DNA, stuff they'd had for years, with brand new consumer genealogy tech, the kind of thing you might use to trace your family tree.
Wow. So it basically redefined what an unsolvable case even means.
Exactly. It fundamentally changed the game.
Okay, so let's break this down for you listening. Our mission today is to really understand investigative genetic genealogy, IGG, they call it. We're going to use the Golden State Killer case as our sort of roadmap.
Yeah, we'll look at the awful history of the crimes, how fragmented it all was.
Then dive into the tech, the actual breakthrough that solved it, which is pretty fascinating in itself.
And importantly, grapple with the big ethical questions this raises. That constant tension between our personal genetic privacy and, keeping the public safe.
Right, it's a tightrope walk, isn't it?
It really is.
Yeah.
So first off, what is IgG? Let's define that.
Good idea.
Okay, so basically take a DNA profile from a crime scene. Forensics generates this.
Yeah.
But instead of just looking for a direct match in, say, the FBI's CODIS database.
Which is what they usually do, right?
Right. With IgG, they convert that forensic profile so it's compatible with public genealogy databases. Think GED match, places like that, where people voluntarily upload their DNA results.
To find relatives.
Exactly. The goal isn't to find the killer directly in the database, it's to find distant relatives, maybe third cousins, fourth cousins, people who share just a small amount of DNA.
Okay, so you find a cousin. Then what?
Then comes the hard part. Intense old-fashioned genealogy, building massive family trees, tracing lines back generations, and then forward again, trying to pinpoint who in that huge family network could possibly be the suspect.
It sounds like finding a needle in a genetic haystack.
That's a perfect way to put it. And understanding why this was necessary requires looking back the sheer terror DeAngelo caused for, 4 decades?
Yeah, let's get into that historical horror. To really get why the 2018 breakthrough was so massive, you have to understand the scope of DeAngelo's crimes and how the system, frankly, failed to connect the dots for so long.
That failure to connect the dots was crucial. For years, police in different parts of California had no idea they were chasing the same person. He kept changing his methods, his location, his identity, effectively.
So where did it all start?
It looks like it began in Visalia, Central California, between 1974 and 75. He was known there as the Visalia Ransacker.
So burglaries.
Over 100 of them. But they were weird, meticulous. He'd break in, rifle through things, but often leave valuables. He moved stuff around, staged things almost. Sometimes left specific objects like ceramic owls, almost like a signature.
That sounds unsettling, like he was practicing something.
That does feel like that in retrospect, yeah. Practicing control, intrusion. And that phase ended violently. He murdered Professor Claude Snelling during a botched kidnapping attempt.
And then he just stopped in Visalia.
Vanished from Visalia and reappeared, it seems, up near Sacramento. That's when he became the East Area Rapist, or EAR. This was from 76 to 79.
Okay, this is the phase people probably know best. The sheer terror he inflicted, it's hard to comprehend. Over 50 rapes.
At least 50 documented. And the level of control, the sadism, it was extreme. He targeted couples, often in their own homes.
I remember reading about the knots he used.
Yeah, intricate, almost professional knots. And the psychological torture, binding the male victim, placing plates or glasses on his back, threatening to kill everyone if he heard a sound.
It wasn't just violence, it was dominance, calculated terror.
Precisely. Prolonged, absolute control over their fear. And then, just as investigators were finally starting to think the Sacramento area rapes might be linked, he shifted again.
Moved south,
primarily Southern California, and escalated. From 79 to 86, he became the original Night Stalker, or ONS. This phase involved at least 13 brutal murders, again, mostly couples.
So let's tally that up. Visalia Ransacker, East Area Rapist, original Night Stalker, at least 13 murders, over 50 rapes, hundreds of burglaries.
Across 6 different counties. And that geographic spread, combined with the siloed nature of police departments back then.
Yeah.
It was a recipe for investigative disaster.
They just weren't talking to each other effectively.
Not like today. Information sharing wasn't standardized. Each county was kind of running its own race, not realizing they were chasing the same shadow. That fragmentation let them operate for over a decade.
Okay, but eventually they got DNA evidence, right, from the crime scenes?
Yes, especially from the later ONS phase, they collected biological evidence.
So, fast forward to the 90s, DNA technology arrives. The FBI sets up CODIS. Why didn't that solve it? Why the long silence?
That's the crux of the problem. It comes down to what kind of DNA analysis CODIS uses and what it's designed for.
Okay, explain that difference, because I think that's key. CODIS DNA versus, 23andMe DNA.
Exactly. CODIS and traditional forensic DNA testing uses STRs, short tandem repeats.
Okay.
Think of STRs as specific spots in your DNA where a short sequence repeats itself, like gotta, gotta, gotta. The number of repeats varies a lot between people. Forensics looks at maybe 13, now usually 20, of these STR locations.
And if they match someone exactly at all those spots?
Then it's a match. Extremely high certainty. Perfect for identifying one person if you already have their profile on file, say from a previous conviction.
Like a fingerprint.
A genetic fingerprint, exactly. But here's the catch for cold cases like the Golden State Killer.
Right.
STRs are terrible for finding family. They change too much across generations. The profile is too small. You might share a few STR markers with a third cousin just by chance. It doesn't reliably show distant relationships.
So D'Angela's DNA profile was collected from crime scenes.
Yes, an STR profile was generated.
But because he'd never been convicted of a felony that required his DNA to be put into CODIS?
Correct, he wasn't in the system. So his crime scene profile just sat there, unmatched, a John Doe profile, waiting for a direct hit that never came.
The technology existed, but the database wasn't designed to cast a wide enough net. It needed that perfect one-to-one match.
Precisely. It was limited by design. That's why the case went cold for decades, becoming this symbol of CODIS's limitations when you don't have the suspect already identified. They needed a different kind of map.
A genetic map. Which brings us to 2018 and this whole new approach. Okay, so we have this old STR profile, basically useless for finding relatives, sitting in a database. How did they possibly bridge that gap to the world of consumer DNA tests, like Ancestry or 23andMe?
That was the technical leap. They needed to convert that limited STR profile into a different type of profile, one that's actually useful for finding family connections. That's the SMP profile.
SMP.
Single nucleotide polymorphism. Don't worry too much about the name. The key thing is, consumer tests like 23andMe look at hundreds of thousands, even millions, of these SMP markers across your entire genome.
Okay, way more data points than the 13 or 20 STRs.
Massively more. And SMPs are much better for genealogy because they're more stable over generations and allow genealogists to see long chunks of identical DNA that you share with relatives, even distant ones.
So how did they get an SMP profile from just the old STR data? That sounds complicated.
It is. They used sophisticated bioinformatics tools and statistical algorithms. Essentially, they took the known STR markers and, based on population genetics data, imputed or predicted what the rest of his SNP profile likely looked like. It's not perfect, but it creates a file that's usable on genealogy sites.
Wow. Okay, so they create this predicted SNP file. Where did they upload it? Not Ancestry, right?
No, not the big commercial sites like Ancestry or 23andMe. They have strict privacy policies and generally require warrants. The key was GED match.
What's different about GE match?
At that time, GED match was more like an open source public utility for genetic genealogists. People would take their raw data file from Ancestry or 23andMe and voluntarily upload it to GED match to find more relatives, compare results, use more advanced tools. Critically, its terms of service didn't explicitly forbid law enforcement use for identifying perpetrators of violent crimes.
So people uploaded their data there knowing it was more public?
Generally, yes. The focus was collaboration and research. So investigators uploaded the killer's SMP profile there.
And bingo, bingo. Did D'Angela's name just pop up?
No, not even close. That's the big misconception. It wasn't magic.
What did they get then?
They got matches, but distant ones. Third cousins, maybe fourth cousins, people who shared a common ancestor with the Golden State Killer way back in the, say, 1800s. Great-great-great-grandparents, maybe.
Okay, that sounds like a lot of potential relatives. How do you get from a third cousin to a suspect?
That's where the human expertise comes in. Specifically, the work of genetic genealogist Barbara Ray Venter. She was a pioneer in using this technique for cold cases.
What did she actually do?
She essentially had to reverse engineer the family tree. She took those distant cousin matches, found how they were related to each other, identified their common ancestors.
Way back in the 1800s.
Exactly.
Yeah.
And then she had to build the family tree forward from that ancestral couple, tracing every single descendant, generation by generation, down to the present day.
That sounds incredibly painstaking.
Oh, it is. We're talking hundreds, maybe thousands of hours of work, digging through census records, birth certificates, marriage licenses, obituaries, old newspaper archives, military records, anything to track people through time and geography.
So she's building this enormous family tree.
A massive tree. And then she starts filtering, looking for male descendants who would have been the right age, and crucially, who lived in or had ties to the specific areas of California where the crimes occurred during the right time periods.
So narrowing it down from potentially thousands of people on that tree.
Down to a small handful of men who fit the geographic and temporal profile. It's incredibly complex genealogical detective work.
And eventually, that process pointed to one name, Joseph James DeAngelo.
Yes, and the profile that emerged was shocking in its normalcy.
The monster next door.
Absolutely. Former police officer in Auburn and Exeter in the 70s, Navy vet, living this quiet suburban life in Citrus Heights near Sacramento, worked at a supermarket distribution center for years, had a family, just blended in.
Which must have been a huge shock.
A profound sociological shock. The guy who terrorized California wasn't some drifter. He was, part of the community fabric.
Okay, but the genealogy only gives you a strong lead, right? You can't arrest someone just based on being related to a third cousin in a database.
Correct. Legally, you need more. You need a direct match between the suspect's DNA and the crime scene DNA. IgG gets you the name. You still need confirmation.
So how did they get DeAngelo's DNA directly without, tipping him off by asking for it?
This is the final crucial step. Covert collection, sometimes called abandoned DNA or throwaway DNA.
Meaning?
Investigators put DeAngelo under surveillance. They waited for him to discard something in public that would likely have his DNA on it.
Like what?
In his case, they reportedly collected DNA from a tissue he threw away in a trash can outside a Hobby Lobby, and also from the door handle of his car while he was shopping.
And that's legal, taking his trash?
Generally, yes. Based on legal precedent, like California v. Greenwood, the idea is that once you abandon property in a public space, you lose your reasonable expectation of privacy in it. The police can collect it without a warrant.
So he literally threw away the evidence that would convict him?
Essentially, yes.
Yeah.
They took those discarded items, got his DNA profile from them, an STR profile this time, the kind used for direct matching.
And compared it to the original crime scene DNA?
They compared it directly to the STR profile from the rapes and murders decades earlier. A perfect match. On 2 separate abandoned samples. That gave them the probable cause they needed for the arrest warrant.
Wow. So the IgG pointed the finger, the abandoned DNA confirmed it.
That sequence IgG lead, covert collection, direct STR confirmation became the blueprint. It showed how to use this powerful new tool legally and effectively.
So DeAngelo's arrested, the news breaks. For the survivors, for the families of the victims. After 40 years of living with this ghost, what did that moment mean?
Oh, it's almost impossible to overstate the psychological impact. It was this overwhelming wave of closure, vindication, relief.
Things they probably thought they'd never get.
Many had absolutely given up hope. Imagine carrying that trauma, the fear, the grief, the violation for decades, knowing the person responsible was just out there, maybe living nearby.
The not knowing must have been agony.
Exactly. So the arrest, the confirmation that he was the one, it validated their experiences. It meant law enforcement hadn't forgotten. It meant they could finally maybe stop looking over their shoulders. It was a release from this generational burden of fear that had haunted entire communities.
But then there's the other side of the shockwave. The fact that he was a former cop, a neighbor, someone who seemed normal.
Right. That's the banality of evil aspect hitting society hard. It shattered assumptions. People want to believe monsters look like monsters, that they live on the fringes.
But he didn't.
He absolutely didn't. He was integrated. He wore a uniform briefly. He lived in a regular house on a regular street. This forced a really uncomfortable realization. Profound evil can wear a mask of complete normalcy.
And that must really shake people's sense of trust, right? Trust in their neighbors, trust in appearances.
Definitely. It fuels that paranoia. Could my neighbor be hiding something horrific? It makes the world feel less safe, less predictable, because the danger isn't necessarily out there. It could be right next door.
There's also that really chilling detail that emerged from the case files over the years, something survivors reported hearing. The whisper.
Yes. That's one of the most haunting pieces of the puzzle. Several survivors, particularly during the East Area rapist phase, reported that during the attack, he would sometimes pause, maybe even sound distressed, Like he was talking to himself and whisper, "I hate you, Bonnie."
I hate you, Bonnie, just out of the blue.
Seemingly. For years, investigators didn't know what to make of it. Was Bonnie a previous victim? A family member? A trigger word? It was just this bizarre, agonizing clue.
Until they identified D'Angelo.
Right. After the arrest, it came out that years before the crime spree began, back when he was younger, Joseph D'Angelo had been engaged to a woman named Bonnie Colwell, and she broke off the engagement.
Wow, so that whisper, it connects the violence directly back to this deep personal wound.
It strongly suggests that yes, it provides this incredibly intimate, disturbing psychological thread. That maybe this decades-long campaign of terror, this need for absolute control over his victims, was somehow fueled by the humiliation and rage he felt from that rejection by Bonnie. It's a glimpse into the monster's pathology.
It's just chilling. And this whole solution, the IgG part, it highlights something else too, doesn't it? About society.
It does. It highlights this new dynamic, this shift in the social contract almost.
How so?
Well, think about it. This massive cold case wasn't solved by some giant government program digging through DNA. It was solved because millions of ordinary people decided, for their own personal reasons, to spit in a tube and send their DNA to a company to find out about their ancestors.
Right, for purely personal curiosity.
Exactly. And that collective voluntary action created this massive, powerful data set. A data set that unintentionally became a tool for law enforcement.
So it's like crowdsourced crime fighting, using our family trees.
In a way, yes. It's a new form of community policing, maybe, but it's incredibly complex because of the implications for privacy. Your decision to test yourself suddenly has implications for all your relative, even distant ones who never tested.
That's the privacy externality idea. My choice affects my cousin's privacy.
Precisely. And the sheer success of the Golden State Killer case, the public good it represented, kind of forced everyone, law enforcement, ethicists, the public, the DNA companies themselves, to confront these really difficult questions head on. The debate exploded right after the arrest.
Okay, so D'Angelo's caught, and almost immediately this huge debate erupts, and it centers on what? The Fourth Amendment, our right to privacy.
Exactly. The Fourth Amendment protects against unreasonable searches and seizures. The core question became, is it an unreasonable search to find a suspect by searching the DNA profile of their innocent relative, who voluntarily put their data online but maybe never intended for it to be used by police?
What do the critics say?
Critics argue that your DNA is uniquely private. It's not just you, it's your whole family, your health predispositions, your ancestry. They argue that searching your third cousin's DNA on GED match to find you is essentially a way to search your genetic information without a warrant, bypassing constitutional protections. It feels like a genetic dragnet.
But law enforcement argues it is legal, right? Based on how these databases work.
Yes. The main legal argument relies on something called the third-party doctrine.
Which means?
Broadly, it means that if you voluntarily share information with a third party, like a phone company, a bank, or in this case, a genealogy website like GED Match, you generally lose your reasonable expectation of privacy in that information.
So because the cousin uploaded their DNA and agreed to GED Match's terms of service,
they arguably consented to the platform's rules, which, at the time, allowed for this kind of search. Law enforcement would say they aren't searching the cousin, they're searching the database the cousin voluntarily contributed to, according to the rules of that database.
It's a tricky distinction. No, we need to bust a myth here. A lot of people probably think the FBI can just dip into Ancestry DNA or 23andMe whenever they want.
That's absolutely not the case, especially not how the Golden State Killer was found. Those big commercial companies have very strict privacy policies. They require warrants or subpoenas for user data and often fight those requests in court.
So the GSK case specifically used GED Match because it was different, more open.
Exactly. GED Match was, at that time, a public-facing tool where users actively shared data for genealogical research. Investigators used its public functionality. They didn't need a warrant to access GED Match's core features back then.
But the minute D'Angelo was arrested using this method, the whole landscape changed, didn't it? The DNA companies reacted.
Oh, immediately. The public reaction was huge. A mix of celebration at the capture and, frankly, a lot of fear about genetic privacy. GED Match, in particular, faced immense pressure.
So what did they do?
They changed their policy dramatically. They moved to an opt-in system for law enforcement matching.
Meaning users now have to actively check a box saying, yes, I consent to let police compare crime scene DNA to my profile.
Precisely. Before, it was more opt-out or the default allowed it. Now the default is privacy, and users must explicitly agree. Other sites followed suit or strengthen their existing policies.
What effect did that have?
Two big effects. First, it significantly shrank the pool of DNA profiles available for law enforcement searches, making IgG harder to perform successfully. Second, it created this confusing mess of different policies across different sites. Consumers are often unsure now who can access their data and under what conditions.
So looking at the overall debate, you've got these two main camps, right?
Pretty much. On one side, you have the justice argument. This is the view held by many in law enforcement, victim advocates, people like Paul Holes who worked the GSK case.
What's their core point?
Their core point is that IgG is a revolutionary tool, a moral imperative even. They argue the immense societal benefit of catching violent criminals, solving brutal cold cases, and bringing closure to victims far outweighs what they see as more speculative privacy concerns of distant relatives who share only a tiny fraction of DNA. For them, it's about justice for the victims.
Okay, and the other side, the critics.
That's the slippery slope argument. This comes often from bioethicists, privacy advocates, civil liberties groups. They see IgG as incredibly powerful, maybe too powerful, and worry about where it leads.
What's the fear?
The fear is mission creep. Okay, we use it today for the Golden State Killer, serial murderer. But what about tomorrow? Could it be used for lower-level felonies, property crimes, tracking political dissidents, immigration enforcement? They argue that without strict legal guardrails now, this technology could easily be abused down the road, leading to a future of widespread genetic surveillance.
So basically, catch killers today versus risk Big Brother tomorrow.
That's the tension, yeah. And it plays out differently around the world, too.
Right, you mentioned the US versus Europe.
Yeah, the cultural context is huge. In the US, we have a strong emphasis on individual rights, but also this massive consumer DNA testing market and a generally more permissive approach, legally speaking, to adopting new forensic tech.
Whereas in Europe
has much stricter data privacy laws, like the GDPR. Plus, there's a deeper historical sensitivity, especially in countries that experienced totalitarian regimes in the 20th century, about the state collecting vast amounts of personal data, especially biological data.
It's like the Stasi in East Germany.
Exactly. That collective memory creates a much higher bar for allowing government access to sensitive information like DNA. So using IgG is legally much more complex and restricted in most European countries compared to the US.
So the Golden State Killer case really opened the floodgates for IgG. But its use has gone beyond just fighting perpetrators, hasn't it?
Absolutely. That's a really important point. IgG is fundamentally about identification. And sometimes the person who needs identifying isn't the criminal, but the victim.
Can you give an example?
A good one is the Palmdale Jane Doe case from 2020. Investigators used IgG to identify a woman who had been murdered way back in 1993. She'd remained unidentified for almost 30 years. Traditional methods, dental records, fingerprints, even searching her DNA in CODIS against missing persons had failed.
So IgG gave her name back.
It traced her family tree, found living relatives, and finally gave her family answers and allowed them to properly grieve. It shows the humanitarian potential of the technology beyond just catching killers.
And it's helping with other really tough cold cases, too.
Definitely. Cases like the Colonial Parkway murders in Virginia, a series of unsolved double homicides from the 80s that had gone completely cold. IgG has reportedly generated new leads where decades of traditional forensics hit dead ends. It's proving to be a powerful complement to CODIS, filling the gap when a direct match isn't available.
Okay, so if we were to sort of sum up the pros and cons now, years after the GSK arrest blew this all open, what are the big takeaways?
Well, the benefits are pretty clear, right? It revolutionizes cold case investigation, especially for violent crimes. It provides answers and closure, which is invaluable for victims' families. And the technology itself, when done correctly, is highly accurate in pointing towards the right family tree.
And the downsides. We've touched on privacy.
Right, the erosion of genetic privacy is the big one. That idea of privacy externalities your test, impacting your relatives. Then there's the slippery slope potential. We discussed the risk of mission creep and broader surveillance if it's not carefully controlled.
And you also mentioned the risk of it not working equally for everyone, the equity issue.
Yes, the disparate impact. This is critical. Consumer DNA databases are overwhelmingly composed of people with European ancestry.
Why is that?
Mostly due to market factors, who the early tests were marketed to, who could afford them, who was interested in certain types of genealogical research.
And the consequence for investigations.
The consequence is that IgG works much better for cases involving suspects or victims of European descent, simply because the database is larger and denser for that population. If the case involves someone from an underrepresented group, say African, Asian, or indigenous ancestry, the chances of finding a useful distant match are significantly lower.
So we could end up with a system where justice is easier to achieve for some groups than for others, purely based on who's in the databases.
That is a serious risk, yes. It could unintentionally bake existing societal biases into the effectiveness of this forensic tool. Addressing that database inequity is a major challenge.
Okay, so given all these benefits and these pretty significant risks, we can't just let this technology run wild. What needs to happen? What are experts suggesting in terms of policy or law?
There's a growing consensus on the need for a clear ethical and legal framework. Relying on company policies isn't enough.
So what should that framework include?
First, clear scope limitation. Most experts agree IgG should only be used for the most serious violent crimes, homicide, serial rape, and for identifying unidentified human remains. It shouldn't be allowed for, say, minor theft or drug possession. That helps prevent the slippery slope.
Makes sense. What else?
Transparency and consent. Standardized rules for how consent is obtained from database users. People need to know exactly what they're agreeing to regarding law enforcement access. No hidden clauses.
And oversight. Should police just be able to decide to do this on their own? No, there needs to be judicial oversight. Many argue that a warrant should be required before uploading a forensic profile to a database. Or, at minimum, some kind of independent review process involving judges or ethical review boards to ensure the search is justified and narrowly tailored. Accountability is key.
And tackling that equity problem.
That's harder, but crucial. It involves investment in research for alternative identification methods, maybe, but also potentially public initiatives to encourage more diverse participation in databases used for forensic purposes, though that's ethically complex too. The goal is to make sure the tool serves justice more equitably.
It really feels like the Golden State Killer case didn't just close a chapter on one monster. It opened a huge, complicated new one about genetics, privacy, and justice. That's exactly right. D'Angelo's capture forced a societal reckoning with the power contained in our own DNA, a reckoning we're still very much in the middle of. #outro. Yeah, when you boil it down, the Golden State Killer case is the perfect storm. It's this incredibly stark example of the 21st century trade-off between our desire for personal privacy and our collective need for public safety and justice. His capture wasn't just an ending, it marked the permanent arrival of genetic technology deep inside the world of law enforcement.
It's like the forensic rulebook got completely rewritten and now it's tied to, how fast consumer tech develops.
Precisely. And IgG isn't just about looking backward at cold cases anymore. It's really a window into our genetic future, showing how decisions we make about our own data, like taking an ancestry test, can ripple outwards in ways we never imagined.
Yeah, that personal choice suddenly has this potential public safety consequence, whether you intended it or not.
Which leaves us, and you listening, with this really profound question, doesn't it? What price are we truly willing to pay for justice? As these DNA databases keep growing, filled with data from millions of us who just wanted to know where we came from, are we okay with building a world where, potentially, every single one of us becomes a searchable node in a permanent, state-accessible genetic network?
A heavy question to end on, definitely something to think about. Thank you for joining us for this deep dive into the Golden State Killer and the genetic revolution of justice.
Thanks for having me.
We'll see you next time on The Deep Dive.